welcome to part 3 of the Kerberos Deep Dive series. My name is Alex, and in part 3 we are looking at an attack called AS rep roasting. If you have missed the previous part 2 about Kerberosting, I suggest to watch this before, as those two attacks are closely related and you'll get some more context. A quick note on the usage of Wireshark throughout those video series. We will be using Wireshark to inspect Kerberos traffic, and Kerberos traffic is at least partially encrypted, which makes the process of analyzing it more difficult. However, with the right key material, Wireshark is able to decrypt all the Kerberos traffic, and that's exactly what has been done for these video series. So whenever we will be looking at Wireshark and you see some parts of the messages with blue background, that means those parts would normally be encrypted and the content would not be available to us. If you want to learn more information about how this was achieved, go back to part 1 of this video series. Now, let's quickly talk about a feature called pre-authentication. We have already touched this subject in the first part of the series, but since this is the basis for the AS rep roasting attack, we will do a quick refresher on it. The Kerberos pre-authentication takes place in the first exchange of Kerberos protocol messages, namely in the AS rec and AS rep part. And the pre-authentication is essentially a feature that requires a user to be authenticated when they request a ticket granting ticket. So the process for this is quite simple. The user will encrypt, or the user's client will encrypt the current timestamp with the secret key, so the long-term key of the user's account. And then this encrypted timestamp is simply added to the first request, so the AS rec. The KDC, since it has access to all the key material of the user as well, will be able to decrypt the timestamp and verify that it is still fresh. So the KDC then knows that the user, first of all, has provided the correct password and therefore is authenticated, and that this message is not a replay attack. Now, pre-authentication is enabled by default for all users within your domain, but you can specifically disable it manually. Now, this is sometimes done for compatibility issues with legacy applications or appliances that might not be able to handle pre-authentication. We can look at a quick example on how this plays out. In our lab setup, I have Wireshark configured with the Kerberos filter, and first we are going to clear all of our existing tickets so we can start from scratch. And then I'm going to issue a request to a file share, and this alone will trigger the Kerberos authentication flow, as you can see in Wireshark. So here we made a request to the file share, and these are the corresponding messages. Now, as we can see in the very first part, or the very first message that is issued, we see this an AS rec, which actually does not include any pre-authentication data into it. The Windows clients don't do that by default, so if we inspect the PA data structure, we see that there's essentially just some flags, but no encrypted timestamp or any other information in there. As a result, the KDC will then check the user and see that pre-authentication is effectively required and return an according error message. Our client will simply then retry the first step, the AS rec, but this time we now see a difference. We see that the PA data structure now, besides those information or those flags from before, includes actually an encrypted timestamp, and the timestamp is encrypted with our user's key material. Now, what is AS rep roasting exactly? Essentially, it's an attack to extract some form of data from the domain that is encrypted with user account credentials or with key material derived from user account credentials that then the attacker can then attempt to crack offline. What it exploits is when you disable Kerberos pre-authentication. So if you don't do that, your accounts will not be vulnerable. But as soon as you check this box on an account, that says do not require Kerberos pre-authentication, this account then becomes susceptible to AES-rep roasting. For this attack, the attacker, similar as with Kerberosting, only interacts with the KDC, so there's no communication to any services besides the KDC itself. And the success of the attack, so being able to brute force the credential, mainly depends on the strength of the password for the affected account, and as with Kerberosting, the encryption algorithms that are used, which could be different ones depending on the setup. So it could be RC4, AES-128, AES-256. Now we can do a quick example on how you can query for users that are configured with disable Kerberos pre-authentication. Currently on the domain controller, but you can do the same from any other machine that has the Active Directory PowerShell module installed. And we can use the get AD user command with a specific filter for the pre-authentication requirement setting. And this will then simply return all the users where Kerberos pre-authentication is disabled. So in our case, we can see that we have one hit, specifically Rebecca Hyde has pre-authentication disabled in our case. Now, what exactly are the consequences of disabling pre-authentication? Why does this lead to an attack? With pre-authentication, or the purpose of pre-authentication is that a TGT for a given user can only be requested when you know this user's password, since you have to encrypt the timestamp with the user's password or key material derived thereof. If you disable pre-authentication, anyone that has network level access to your domain controller or the KDC can request a TGT for that affected user. What is good to know is that the TGT itself, however, is only usable if you also have the associated session key. If you go back to part 1 of this video, you find more information about the association between the session key and the actual ticket. But essentially, you have to know that a TGT itself is only valid and usable if you have the corresponding session key. Now, the session key, when it is transferred back to the user, is always encrypted with the target's user key material. So no matter whether we provide a password or have the password for the Kerberos pre-authentication and perform it or don't perform it, the session key is always encrypted with the long-term secret of the target account. That means if we don't have the password, we can request a TGT if pre-authentication is disabled, but we will not be able to simply decrypt the session key and therefore use the TGT. So the TGT is not usable for us unless we know the password. However, what we can then attempt as an attacker is to take this encrypted session key and try to crack it or to brute force it to recover the password. So we can quickly look at this in more detail. This is essentially a recap of the first part of this video series. If we inspect or see what happens in this AES-rep part of the protocol flow, we see that two things are exchanged or sent back from the KDC to our user. Once we have the TGT, so the ticket granting ticket. This ticket granting ticket is encrypted with the secret key or the key material from the KRB TGT account. So there's not much we can do there since this account has a randomly generated password. But besides that, we also have this session key that is associated with this TGT. And the session key part of the message is encrypted, as we've talked about before, with the long-term secret or the Kerberos key material derived from the user's account password. So this is essentially the target of our brute forcing attacks. If you go back to Wireshark again, here I have a pre-recorded Kerberos authentication flow, and specifically we will be looking at the AES-rep part of the message, so where we get the TGT and the encrypted session key back. If we dig into the structure of this, we see those two parts, the ticket and the enc part, which contains the session key. Now we can inspect what key material has been used to encrypt those parts respectively. For the ticket itself, if we open this part of the message, we see, as expected, the KRB TGT account as a source for the credentials. And for the enc part, which contains the session key, this part of the message with the session key right here was indeed encrypted with the key material associated with the target's user account. So the key material derived from the user's password. Now, how exactly does the attack work? Essentially, it's very similar to the Kerberos attack, so part 2 of this video series. If we look at how TGTs are requested or what the process is behind this, if a user requests a TGT, the TGT and the associated session key are encrypted, respectively, with different key material. For the session key specifically, this is a Kerberos key derived from the user's password. So now what we do to attack this is simply to flip around the process and start with a password. So we take any password candidate you might want to use, in our case password 1. You then derive the key material from that, and here it's good to remember that this derivation of key material is standardized. So whatever encryption algorithm was used, be that RC4, AES-128 or 256, the RFC of these encryption algorithms specify how exactly the key derivation is performed. So this is well known and documented. So then once we have the key material derived, we attempt to decrypt the session key that we got from our exchange. And then we validate the outcome. If the decryption is successful and we get a valid session key data structure, we have indeed cracked the password, so we have taken the right password candidate. And if the decryption fails, so we get garbled information, we simply choose a new password like password 2 and repeat the process over and over until we either run out of time or we find the right password. Now onto the requirements and constraints for this attack. For performing AES-rep roasting, we have learned that there has to be some account where Kerberos pre-authentication is disabled. Without this configured, there is nothing you can do. So out of the box, none of the users in a domain are vulnerable to AES-rep roasting, but as soon as you disable pre-authentication, this will be the case. Furthermore, we also need a network connection to a KDC, so a domain controller, to request a ticket. However, we don't actually, as an attacker, need a valid account. So no domain account is required to perform this attack. The only part where you would require an attack is if you want to query beforehand users where the pre-authentication is disabled. But if you either know that information already or simply try your luck with a specific or all accounts in the domain, you don't need a valid domain account. And as with Kerberos, again, targeting machine accounts doesn't make sense since the machine account password is handled automatically by Active Directory. The password is randomly generated every 30 days and about 120 characters long, so you will not be able to crack it. Now, we are going to use some different tools to actually perform a AES-rep roasting attack. First, let's use Rubeus. Rubeus has a built-in command called AES-rep roast, and we can then also specify the format for the output. So, for example, Hashcat, if we want to use Hashcat to crack the outcome, and then we specify an output file. As we can see, the user that we have identified before, Rebecca Hyde, was indeed AES-rep roasted now. Rubeus has built an AES-rec without pre-authentication, and this was successful since pre-authentication is disabled for this account. And then we have the contents written out to the file that we specified. If we look at that, we can see that the notation depicts what type of message this is. So this is an AES-rep with the encryption type 23, which maps to RC4 for the user R-hide, and whatever follows after that is the actual encrypted data that we will then attempt to brute force. If we look at this part in Wireshark, we can see essentially the same thing. We see an AES-rec without any pre-authentication data. And in comparison to what we've seen before, where the KDC would return an error, this time we actually simply get the TGT and along with that also the encrypted session key back, since pre-authentication is disabled. Now the ticket, remember, is encrypted with the KRB TGT accounts key material, so it's no use to us, but the encrypted part, which carries or contains the session key, is actually encrypted using the key material of our target user account, so of Rebecca Hyde in our case. And this will then be the part that we will attempt to crack. And this, if you can compare those two strings, you can see that this is actually the same data contained in there. Now, if you want to do the same attack, let's say from a Linux system, I'm on my Kali machine here, which simply has network connection to the domain controller. We can use a tool from the Impacket suite, namely get np users. And in this case here, now we will specify account credentials. Now, I've said before that ASRep roasting doesn't need a valid account. Here we simply provide the account credentials so we can query the domain for users that have pre-authentication disabled. So that's the only reason for that. We can also again specify the format for cracking and the output file. And then once we perform or we provide the password, this should work as well. Remember, we also have to provide the IP of the domain controller, since our machine is not domain joined and therefore doesn't know where the domain controller is. As a result, we can see that indeed, as expected, the same user was identified, Rebecca Hyde, which has pre-authentication disabled, and the output looks about the same as we've seen before with Rubeus. So again, the same message type, the hash or the encrypted data in this case that we want to brute force later on. Now again, some more details on the output of those tools. Typically, they are structured in this way here. The first type indicates the first part indicates the message type. So this, whatever is contained in here, is the result of an ASRep message. We have then the encryption type, as mentioned before. In our case, this maps to RC4. The affected or associated user account, and everything behind that is the encrypted ticket, or in our case, the encrypted session key that we want to crack. For cracking itself, we this time simply use Hashcat. I'm back on the Kali machine, and what we have prepared here is simply the output from before, as well as long as we've seen in the previous example, and we have a word list as well, ROCU in our case. Of course, you would have to choose an appropriate word list for your case. Now, for Hashcat, we have to specify the algorithm ID. This you can simply look up online. So we see algorithm 18200 maps to KRB5 ASRep with encryption type 23. And this can then be specified along with the word list, and that should be enough to, in our case, crack the collected session key. And of course, this goes quite fast since this is set for demo purposes, so we have a very weak password in our case, but this essentially demonstrates how ASRep roasting can lead to compromise of the user account's password. Now, what are the countermeasures? What should you do to prevent this? It's quite simple, actually. Don't disable Kerberos pre-authentication. So if there's no need for that, you should never do that. And along with that, if you ever have to do it, and it's a good idea on its own, is to deploy a strong password policy and make your users aware on how to choose strong passwords. Furthermore, in case an attacker still successfully compromises an account, it's always a good idea to restrict the privileges of all your users according to the least privileges principle. And then what you can do periodically is to actively check for ASRep roastable accounts. So with the PowerShell command we've seen before with LDAP queries, you can simply check your domain for accounts that are susceptible to ASRep roasting. By the way, Pincastle will also point that out to you. And lastly, you can also implement monitoring if you enable the audit Kerberos service ticket operations on your domain controllers. And remember, enable it on all your domain controllers because the attacker might talk to different systems. And then you can look for TGT request events, since this is the event that will return the crackable information, and correlate these requests specifically with accounts that do not require Kerberos pre-authentication. This has been part 3 of our Kerberos deep dive series. Please feel free to leave a comment if you have any questions or remarks. Thanks for watching.